Chapter 2, Sections 4 and 5. We'll start with Section 4, which is multiplying rational numbers. So our two objectives for Chapter 2, Section 4 are that I can multiply fractions and I can multiply terminating decimals. When we first learned multiplication, it was because we had been doing repeated addition, and it was a faster method. So I could add 1/4 plus 1/4 plus 1/4 and count it all up to equal 3/4. Or I could go 3 times 1/4 and speed up the process to get 3/4. Multiplying a fraction by a whole number is the same process as multiplying the whole number by just the numerator of the fraction and keeping the same denominator. As a quick reminder, multiplying rational numbers. Positive times a positive is a positive. Negative times a negative is a positive. If the signs of the factors are the same for two rational numbers, the product is positive. If the signs for two rational numbers are different, the product is negative. Let's look at a couple examples. Mark runs 1/7 of a mile each day. What is the total distance Mark runs in a 5-day week? This is like repeated addition, so we could speed up the process. 5 times a week, Mark runs 1/7 of a mile. So that's 1/7 times 5. We said before that 5 is a whole number. Multiplying a whole number times a fraction is just multiplying the numerator of that fraction. We could also write 5 as 5/1 as an improper fraction to show that it's just numerator times numerator, denominator times denominator. So we have 1 times 5 and 7 times 1 giving us 5/7. So Mark runs 5/7 of a mile in a 5-day week. Excuse me, that should say 5 days. Okay, first example in your notes. It says multiply, write the answer in simplest form. -8 times 6/7. -8 is like -8/1, so we just multiply the numerator times -8. So -8 times 6 is -48, and -48 is over the denominator of 7. We could go ahead and make that a decimal. We could also leave it as improper. We could make it a mixed number. I'm fine with leaving it improper. Another example, if we are multiplying where we have a whole number and a mixed number, best method to follow is to make the mixed number into an improper fraction. You can see in the blue how we do that. It's the whole number times the denominator plus the numerator over the original denominator. So 5 times 3 plus 1, which is how we get 16/3. Now we'd multiply 2 times 16/3, which would just be 2 times 16, 32, divided by 3. And again, we could leave it that way, and that's fine with me. A fraction is in lowest terms or simplest form when the numerator and denominator have no common factors. This example will show us another method that we can use to get to simplest form. 1/8 times 6/7. We can go ahead and multiply the numerators, 1 times 6, 8 times 7. However, if we have common factors in the numerators and denominators, we can simplify before we multiply. For example, 6 and 8 share a common factor of 2. We can divide both of those values by 2 to reduce them. 6 divided by 2 is 3. 8 divided by 2 is 4. Now it's 1 times 3 and 4 times 7, giving us 3/28, which is already in simplest form. Let's try one in your notes. -2/3 times 9/2. So -2 times 9, 3 times 2. Well, we know that we can reduce factors of 9 and 3. Those divide by 3. 2 and 2 divide by 1. So now we're reduced to -1 times 3/1 times 1. We get an answer of -3/1, which we don't need the 1 because it's going to end up staying -3. For decimals, you can use lattice multiplication, you can use the old school multiplication. It doesn't matter to me. If we need to multiply 2 times -0.51, We know a positive times a negative is a negative, so we put that down right away and we don't have to worry about it. If you just multiply 2 times 51, you'll get a number. You move the decimal 2 spots to the left from where it was on the end, and you have your value. So negative 1.02. Same thing for B. We can multiply 375 times 4, move the decimal 3 spots to the left, and we'll have our value. We know a negative times a negative is a positive. When we multiply those out, we get 1.5. We wouldn't need the zeros at the end. They were there because of our original multiplication before we moved the decimal. That's the end of Chapter 2, Section 4.